Bismillahirrahmanirrahim. Assalamu alaikum, dear students. Today we have another topic that is 8.4 speed of sound. Okay, speed of sound, and we know that sound is a longitudinal wave. So, speed of sound is equal to Young modulus divided by rho under root. Okay, now here from this formula, we know that speed of sound depends upon elasticity of the medium and the density of the medium. अपन दचर खबोज यार बंगुने रहता वही वीडियो के बंग रही हम speed of sound depends upon two things, modulus of elasticity and the density of the medium. Okay, the first scientist who discusses the speed of sound, that is Newton's hypothesis. So Newton said that the sound travels through air and other gases under isothermal conditions. And what is isothermal conditions? Iso means same, thermal mean temperature, which means that when sound waves travel in air, there is no change in the temperature. So there is no change in the temperature. Iso means same, thermal mean temperature. So it means the temperature is constant here. So what does it mean? It means that temperature is constant. If temperature is constant, then volume and pressure will be inversely proportional according to Boyle's law. So Boyle's law representing isothermal process. Okay, so volume and pressure are inversely proportional and temperature is constant. So if you remove the proportionality sign, so we will place constant K and shift the P to the left hand side, so it will be PV is equal to K, and we can write it as P1 V1 is equal to P2 V2. This is called Boyle's law, or this is called isothermal process. Okay, so sound travel in isothermal process, this hypothesis is given by Newton's. Okay, suppose we have a tuning fork, there are air molecules. Okay, now the initial pressure of the medium is P and initial volume is V. Okay, now if we strike the tuning fork, so it means that the prongs will start vibration and it will produce compression and rarefaction. Okay, so look at the compression. Compression means when the molecule get closer. So it means that if the molecule get closer to one another, so its volume will be decreased, V minus delta V. So minus delta V means the volume is decreased and the pressure will be increased. So P plus delta P. So the final pressure will be increased. So initial pressure is P, final pressure is P plus delta P. Initial volume was V, the new volume is V minus delta V. So in the compression, volume will be get decreased, pressure will be get increased. So putting these values in the equation number 1. So look at equation number 1. In equation number 1, P1 V1 is equal to P2 V2. This equation number 1. This is called isothermal process, or this is called Boyle's law. So putting the value of P1, P, V1 V, and P2 is P plus delta P, and V2 is V minus delta V. Okay, now multiplying simply these equations to one another. So P into V, PV minus P delta V plus V delta P minus delta P delta V. Okay, remember delta P means the small change in pressure, delta V means the small change in volume. Okay, this is small change in pressure, this is small change in volume. So small multiplied by small, so it will be get more small. Small number multiplied by small number, so it will be get more smaller. So it means that we can neglect it. Okay. Okay. Now the small change in pressure and small change in volume will be cancelled. So it will be neglected. Why it is neglected? Because small change in pressure and small change in volume when multiplied to one another, so it will be get more smaller. so which is negligible. Okay, now shift PV to the left hand side, so it will be PV minus P delta V plus V delta P minus 0, so this is neglected, and PV minus PV is 0, so it will be minus P delta V plus V delta P. Okay, now shift this minus P delta V to the left, so it will be P delta V is equal to V delta P. Okay, now divide delta V on both sides, so it will be V delta P divided by delta V. Okay, shift this volume to the bottom, so it will be delta P divided by delta V by V. So this V comes down in the double divisions. Yes, as we can shift the term from the double division to the up, so likewise we can shift the up terms to the double division. Okay, now what is delta P? Delta P is force per unit area, and delta V by V. Okay, what is force per unit area? Stress. What is change in volume per unit volume? Strain. So putting here the definition of this is the definition of stress, so I write it as stress, and this is the definition of strain, so I write it as strain. And what is stress by strain? Young's modulus or bulk modulus. Okay, so pressure according to Newton's hypothesis is equal to the Young's modulus. Okay, so pressure and Young's modulus both are equal to one another. Okay, now look at here. What is the speed of sound? E by rho under root. This is the speed of sound. Okay, now if you put the value of Young's modulus here, which is pressure according to Newton's hypothesis, and pressure is equal to rho gh, so the value of the density of mercury is 13.6 in CGS system, and the value of G is 981 in CGS system, and the value of height is 76 centimeter in barometer, and the density of air is 0.0012 in CGS system. So I put it all the value in CGS system, so I'll get 281 meter per second is the speed of sound, which is obtained by the Newton's hypothesis, from the Newton hypothesis. So this speed of sound is wrong. Actually, the actual speed of sound is 332 meter per second. This is the actual speed of sound. This is the accurate. This is wrong. Here 16% error is found in this value. So this value is not acceptable. So it means that Newton was wrong. So actually speed of sound is not an isothermal process. Speed of sound is not traveling under isothermal conditions. Okay. Now, another scientist in topic number 8.41, Laplace comes and he made the correction. So this is called Laplace correction. Okay. So Laplace made that correction. He said that he was a French mathematician. He explained that sound travel in adiabatic condition. So the formula for what is adiabatic? First look to the adiabatic process. What is adiabatic process? Adiabatic process means when the amount of heat will remains constant. Okay, so what is the equation? Here the pressure and volume are inversely, so pressure is inversely proportional to 1 over volume V power gamma. What is gamma? Gamma is a number. Gamma is a pure number. Why I'm called it number? Because the ratio of the same quantity is called a number. The ratio of the same quantity is always a number. Okay, so gamma is a number. Why it is called a number? Look, it is the ratio of the specific heat at constant pressure to the specific heat at constant volume, so that is why I'm called it a number. So specific heat at constant pressure, the unit of specific heat at constant pressure is joule per mole per Kelvin, and the value of specific heat at constant volume is joule per mole per Kelvin. So they will be cancelled here, so it means that it is a pure number. So remember, gamma is always greater than 1. Why it is always greater than 1? Because Cp is always greater than Cv. So if the Cp is always greater than Cv, so gamma is always greater than 1. Okay, So the value of the gamma is 1.41. Okay, this is the value of gamma. So pressure and volume are inversely with respect to v power whole gamma. Okay, now if you remove the proportionality sign, so we will place a constant k. So if you shift the volume to the left hand side, so it will be p v power gamma is equal to k, and we can write this equation as p1 v1 power gamma is equal to p2 v2 power gamma. This label is equation number 1, or this is called the adiabatic equation, or this is called the equation in which the heat is constant, okay. So this is the adiabatic equation. So look at to the air, these are the air molecules, okay. Now the initial pressure is P, the initial volume is V, okay. Now if we strike the tuning fork, so the tuning fork will start vibration. So the tuning fork will start vibration, so compression and rarefaction will produce compression, and rarefaction will produce. So here compression means the pressure is increased, P plus delta P, and compression means the volume is decreased, so V minus delta V, okay. So putting these values in equation number 1, so look, P V power gamma is equal to P plus delta P into V minus delta V. So putting all these values in equation number 1, so we get this equation, okay. Now I want to take common V from here. So look, P plus delta P, so take V as a common, so V is equal to, so it will be 1 minus delta V by V whole power gamma. When we take common V as a V common, so it will have its own power V power gamma. So V power gamma will be cancelled. So it will be P is equal to P plus delta P into 1 minus delta V by V whole power gamma. This label is equation number 2, okay. Now why we took V is a common? Because we want to introduce 1 here. Why we want to introduce 1? To make it binomial expansion. For the binomial expansion, it is necessary that the first term should be 1. Should. If the first term is 1, then we can use binomial expansion. So what is the formula for the binomial expansion? But the formula for the binomial expansion is 1 minus y whole power n. The first term should be 1, the second term may be any terms, so I write it as y and whole power n. So its formula is equal to 1 minus power multiplied by the second term. This is called the binomial expansion. 1 minus power multiplied by the second term. So use this formula over here in equation number 2. So what we will get, look, P plus delta P into 1 minus power multiplied by the second term. So we use binomial expansion here, okay. Now simply multiply these terms to one another. So look, P multiplied by 1 is P, and it is gamma P delta V by V, and delta P multiplied by 1 is delta P, okay, and minus delta P delta V by V, okay. Now again look, delta P is a small change in pressure, delta V is a small change in volume, so small change multiplied by small change, so the value will be get more smaller. So if the value is get more smaller, it means that we can neglect this value. So this value is neglected from here, okay. Now look at to this equation, shift this P to the left hand side. Here it is positive. If you shift it to the left hand side, so it will be get negative, so it will be P minus P, okay. Now the right hand side is minus gamma P delta V by V and plus delta P minus 0, okay. The other term is being neglected, so I write it 0. So P minus P is cancelled, so it is 0, minus gamma P delta V by V plus delta P, okay. Shift this minus term to the left hand side, so it will be positive. Gamma P delta V by V is equal to delta P, okay. Divide this delta V by V on both sides, so we will get gamma P is equal to delta P, delta P divided by delta V by V. So I divide delta V by V on both sides. So when you divide on both sides, so we will get this equation. What is delta P? Delta P is actually force per unit area, and delta V by V. Okay. What is force per unit area? Force per unit area is called the stress. And what is change in volume per unit volume? That is called the strain. Okay. And stress by strain is called the Young's modulus or the bulk modulus. So modulus of elasticity is equal to gamma P. Modulus of elasticity is equal to gamma P according to Laplace. According to Laplace correction. Okay. According to Laplace correction, modulus of elasticity is equal to gamma P. Okay. Now putting these values in the equation of speed of sound. What is the equation of speed of sound? Equation of speed of sound is E by rho under root. What is E? E is proved by Laplace, that is gamma P. So putting this value here, so it will be V into gamma P by rho under root. What is the value of P? P is equal to rho GH. So putting all these values here, what is the value of gamma? 1.41. What is the value of density of mercury? 13.6. What is the value of G in CGS? 981. What is the value of height? 76 centimeter. What is the value of density of air in CGS? 0.0012 and under root. Okay, so we will get 333 meter per second, which is the exact speed of sound. So it is proof mathematically that speed of sound depends upon speed of sound traveling in a medium under adiabatic condition. So it is proof speed of sound is traveling in a medium as under adiabatic conditions. Okay, now this is 8.4.1. now another topic is 8.4.2, which is effects of various factors on speed of sound in air. Effects of speed of sound in air. Okay. The first thing is speed of sound is equal to E by rho under root. So remember, speed of sound depends upon the density. Yes. Speed of sound depends upon the elasticity. Speed of sound depends upon the density. So if speed of sound depends upon the density, so it means that when we talk about the moisture, when there is a moisture mean air plus water. When the molecule of air is attached to the water, that is called moisture, or that is called dew, or that is called humidity. These are the similar names of this moisture. Okay, so when the air molecule attached to the molecule of water, so that is called moisture. When moisture occur, the density of the medium decreased. So if the density of the medium decreased, the speed of sound will be increased. Okay, so from in the moisture medium, the speed of sound is greater. So dryness and moisture are opposite term. It means that in the dryness the density is larger, so the speed of sound will be smaller. In the moisture the density is smaller, so it means that the speed of sound will be greater. So remember, speed of sound is not depending upon the pressure. Speed of sound is not depending upon the pressure, the number of moles, and the ideal gas constant. These are the independent terms for the speed of sound. So look, speed of sound is equal to modulus of elasticity by rho. So when we put according to Laplace gamma P here, okay, so if someone say that the pressure is 4 times, the MCQs comes in eta or MDCAT is when the pressure is 4 times. So remember, pressure is equal to rho GH. So if the pressure is 4 times, the density will also be 4 times. So look at here. So if the pressure is 4 times, density is 4 times, 4 times will be cancelled. So speed of sound will be remain the same. So 4 times will be cancelled. Speed of sound will remain the same. So speed of sound is not dependent upon the pressure of the medium. Okay, leave it. The formula for the speed of sound according to Laplace is gamma P by rho, And what is P from ideal gas equation? From the ideal gas equation, P is equal to nRT by V. Okay, this is the value of pressure from ideal gas equation. And what is the definition of density? We know that mass per unit volume. So volume will be cancelled. So uh, it will be V is equal to gamma nRT divided by M. Okay. Now, what is the definition of number of moles? Number of moles, the definition of number of moles is mass by molar mass, nRT by M under root. So mm will be cancelled. So the speed of sound, the final equation for the speed of sound is gamma RT divided by molar mass. Okay. So the speed of sound depends upon gamma. No, gamma is constant. Ideal gas constant. No, ideal gas constant is a universal constant. Molar mass. No, molar mass depends upon the nature of the medium, the nature of the molecules. Each and every molecule have different molar mass. So it means the speed of sound depends upon nature of the medium. Okay. The one thing that is temperature of the environment. So speed of sound is directly proportional to temperature of the environment. So we can write this equation as in this form. So speed of sound and temperature are directly proportional in square root form. Okay. Now look at here. If I say the initial pressure, the initial temperature is T naught, then the initial speed will be V naught. The final temperature is T, the final speed will be T. Okay. So remember, what is T naught? T naught is 0 degree centigrade or 273 Kelvin. Okay. If you remove the proportionality sign, we will place constant. If you remove the proportionality sign, we will place constant. So it will be T naught. So divide this equation by this equation. So what we will have, V by V naught is equal to K under root T divided by K under root T naught. So K will be cancelled. So write it in the single under root. So it will be T by T naught. What is T? Final temperature. What is T naught? Initial temperature. Okay. T naught is initial temperature. So putting the value of final temperature. So final temperature is initial plus change. And this is initial temperature. And what is the value of under root? The value of under root is 1 over 2. Okay. First split this LCM over here. So T naught by T naught plus delta T divided by T naught whole power 1 over 2. So T naught will be cancelled. So it will be 1 plus delta T divided by T naught whole power 1 over 2. So this becomes binomial expansion. So what is the formula for the binomial expansion? The formula for the binomial expansion is 1 plus power multiplied by the second term. Okay. So what is T naught? The value of T naught is 273 Kelvin. So putting the value of T naught over here, so it will be 273 Kelvin. So it will be 546. Yes. V by V naught is equal to 1 plus delta T divided by 546. Okay. Now I want to vanish this V naught from here. So multiplied V naught on both sides. So what we have, look, I'm writing that equation again. V by V naught is equal to 1 plus delta T divided by 546. Okay. Now multiplying this V naught on both sides. So I multiplied this V naught on both sides. So V naught will be cancelled. So V naught will be multiplied inside with both the terms. So V naught plus V naught delta T divided by 546. Okay. So what is the value of V naught? V naught is the initial speed, which is equal to 332 meter per second. The speed of sound at 0 Kelvin. The speed of sound at 0 degree centigrade, or speed of sound at 273 Kelvin. Okay. So 546 and 332 will be cancelled. So the formula will be V naught plus 0.61 delta T. So when they cancel, we will get 0.61. So this is the final speed of sound. So this equation tells that whenever you bring change in the temperature, the speed of sound will be changed. So this formula shows the exact speed of sound. Value of speed of sound. Okay. Remember, speed of sound is also depending upon the speed of winds. When the air is moving along the when the sound is moving along the direction of the wind, then the speed of sound will be greater, and when it is moving opposite to the direction of wind, so it will be, the speed of sound will be smaller. So this you already study in a metric classes. So the direction of the wind is also important for the speed of sound. Okay. uh, if you have any question, any query about this topic, you can ask in comment section. Okay, take care. Allah Hafiz.